If a board passes factory testing but later starts freezing, rebooting, or failing after running for a while, the problem may be hiding in solder joists you cannot see. With components such as BGAs and QFNs, the solder joists are underneath the package. If weak joists, bridging, or avoiding are not detected, they may affect the long-term reliability of the product. There are 4 key steps behind reliable heating solder joists. Here are how we control them. First, solder paste printing. Too little solder paste can lead to insufficient solder or unreliable connections. Too much paste can increase the risk of bridging, short circuits, and other soldering defects. To control this process, we optimize stencil apertures based on path size and component type. We also control solder paste condition and printing parameters to keep the deposits consistent across the paths. After printing, SPI checks the area, height, and volume of the solder paste. This allows us to identify issues such as insufficient paste, excess paste, or misalignment before place begins. Stable solder paste printing gives placement and reflow a reliable foundation. Second, placement accuracy. BGA solder boards are closely spaced. If the placement offset is too large, connection issues may appear after reflow. To control this process, we verify the placement program and component coordinates. We also complete first article confirmation before moving into volume production, helping each component landing accurately on its corresponding path. Third, the reflow profile. Different boards require different reflow settings depending on board thickness, copper distribution, component size, and solder paste type. For this process, we use a 12-zone reflow oven and fine-tune the setting for each product. The solder joists heat up gradually, fully flow, and then cool down in a controlled way. After reflow, the joists are well formed, and the connections between the components and paths are more stable. Fourth, X-ray inspection. The solder joists underneath BGAs and QFNs cannot be evaluated through visual inspection alone. We use X-ray imaging to inspect these hidden joists and check for insufficient solder, bridging, voiding, misalignment, and other abnormalities. This makes the condition of the hidden solder joists visible and helps prevent defects from moving into the next stage. Long-term reliability is not just about whether a board powered up when it leaves the factory. At Fastern, we do more than place components on a PCB. We maintain strict process control during solder paste printing, component placement, reflow soldering, and inspection. If you have a PCB fabrication or assembly project, contact us to discuss your requirements.